group theorems today. So the first one is show that in a infinite cyclic group, so that in an infinite cyclic number of generators are 2. Now because this is an infinite cyclic group, let A be generator. So every element is of the form x is x. So x belongs to z. So x will be of the form a power n, right? For some n belongs to n, for all x belongs to g. So also if a power small m is equal to e, then m has to be 0 because it is infinite order. Now let B be another generator. Okay. Now what happens was, let's say the same x will be of the form, so x is equal to say b, right? Now b will be of the form a power some m, right? Because since b belongs to g and g is generated by a. Similarly, a is of the form b power n, right? Since a belongs to g and g is equal to, now if you combine this, right, b is equal to 2 in 1, this implies b is equal to b power mn, this implies b power mn minus 1 is equal to e. But since it is infinite cyclic group, mn should be 1, right? Say a not equal to b, otherwise there is no point. It implies m is equal to minus 1 or m is equal to minus 1, n is equal to minus 1, or m equal to 1, n equal to 1. If put this here, this implies b is equal to a inverse. So if you put here b is equal to a, right? If you put this in 1, so b is equal to a won't be the solution because we already taken a not equal to b. So b is equal to a inverse. So if a is generator, then another generator should be a inverse. So this is the first one. Theorem 2. If G is equal to A is finite cyclic group, right, of order n, then A power m is generator of G if and only if means both sides have to show, right, 0 less than n, and GCD of m common is 1. Okay, so let us prove this. Say it is saying a power m is generator. See, a power m is, so let us do this side, right? So if G is equal to, if a power m is generator of the gen, GCD of m comma n is 1. First we will prove this way, later we will prove this way. First one we are proving this. Now a power m is generator of a power m is generator of G, right? So this implies a power mj is equal to a, right? For some j belongs to j. A power mj is basically a power m whole power j, right? Because so this implies a power mj equal to a into a power minus ni. Since a power n is e a power ni is equal to e, a power minus ni is equal to e. Okay. So this implies a power mj plus ni is equal to e. Right. Okay. So this implies a power mj minus 1 is equal to e, right? So this implies order of n divides mj minus 1, right? So this implies n into some I is equal to mj minus 1. So 1 is equal to mj plus n into minus I. So there exists minus I comma j belongs to z such that mx plus ny is equal to 1. This means GCD of m comma n is 1. This is by Bijout's lemma. Bijout's lemma is two-way, right? So GCD of m comma n is 1. Then there exists x comma y belongs to z such that mx plus ny is equal to 1. This way is also true. If there exists x comma y belongs to z such that mx plus ny equal to 1, then GCD of mn equal to 1. Now the second part, right? GCD of m comma n is equal to 1, then a power m is also a generator. See if okay. See, if GCD of m comma n is 1, then there exists, so we are proving this way, right? GCD of m comma n is 1, then there exists I comma j then there exists I comma j such that mi plus nj is equal to 1, right? So a is equal to a power mi plus nj. But since n is, so this implies a is equal to a power mi, right? For all a belongs to g, we can write it, right? Because I belongs to z, some z. Therefore, g is equal to a power m. Sorry, a is now for all x belongs to g. Sorry, a is generator, right? It is unique. So for all x belongs to g, x is a power n, right? But this is a power min. A power m. Sorry, let's take it as lambda. Lambda belongs to z, right? A power mi lambda. A power m I lambda. Therefore, a power m is a generator because I lambda belongs to z, and for all x belongs to r, we can write this as. So in a power 1 and so on a power n, right? This will be the g, right? Because if you into a, then you will be coming back here. That's the whole concept of cyclic group, right? So if I so number of generators will be phi of n, right? Phi of n is 1 less than or equal to k less than or equal to n, such that GCD of k comma n is equal to 1.